This deep dive is taking place in the middle of the series, however, in many ways, this could be presented at the end, since this presentation reveals the end state of the DoD Cloud IAC. Understanding the environment that the code is attempting to create will help you understand why the DoD Cloud IAC created the environment in the manner that it does. As we start this analysis, we are going to take a short 10,000-foot view of how these federal environments are configured.
These yellow, blue, brown and gray pictures represent a high-level depiction of international networks across the globe. Each of these images represents a large number of telecommunication wires being laid across the planet. Some of these wires are shared, other sets of wires are dedicated. There are an estimated 550,000 miles of wires used to create the Internet. The DoD maintains two separate sets of wires that are used to maintain classified and non-classified DoD communications. Also, the intelligence community has its set of wires. These are used to maintain the Joint Worldwide Intelligence Communication System. Each set of wires hosts its own network. The NIPRNet is the Non-Classified Internet Protocol Router Network, used for non-classified data processed in the DoD. The SCCA is the Secret Internet Protocol Router Network, used for classified data processed in the DoD. The JWICS is the Joint Worldwide Intelligence Communication System, used by the intelligence community. And, of course, the Internet, used to connect the public.
Each of these networks shown has one or more types of cloud data centers dedicated. MilCloud 1.0, also known as Stratus, is located in the DISA facility and resides on the NIPRNet network. The SCCA has its own network which is supported by DoD secret cloud data centers. And JWICS, which supports the intelligence services, has its own set of high-security cloud data centers. The Internet, depicted on the bottom, hosts two types of cloud data centers, both the public cloud data centers and the government cloud data centers.
The Department of Defense Cloud Computing Security Requirements Guide provides the guidance of how to treat the workload under the different security profiles. In DoD terms, these security profiles are referred to as impact levels. The guide is often referred to by its acronym, the CCSRG, and there are 4 security impact levels defined in the CCSRG.
We see the 4 impact levels of the DoD here. Note that the number assignment skips around a bit. Originally there were 6 impact levels, but impact level 1 and 3 were removed since much of their functionality was redundant with other impact levels. The current impact levels can be defined in the following manner. Impact level 2, public information, like a cafeteria menu. Impact level 4, secure info, but not related to national security, like credit card data or social security numbers. Impact level 5, secure data which is related to national security, but not secret, like crew manifest used for vessel targeting. Impact level 6, secret data, like travel information for military officers. Each of these impact levels has a different set of security requirements. For example, an application at impact level 2 may be allowed to exist in a general usage cloud data center, accessible by anyone in the world, whereas an impact level 6 application can only be accessed by people on the SCCA who have clearance. For this analysis, we will first take a quick look at impact level 2 traffic, and then impact level 4 and 5.
Connecting from the numerous global networks require a networking concept called an access point. In the diagram, you can see how NIPRNet is connected to its cloud data centers on the Internet through a dedicated boundary cloud access point, also known as the BCAP. The government cloud is a set of cloud data centers used by many government organizations. These include other federal agencies, state government, city governments, and even police departments. This is a bit more complex than the other DoD cloud environments, since it exists on the public Internet. This government cloud is also referred to as the GovCloud. In the case of applications with little security requirements, like impact level 2 applications, either the GovCloud or the public cloud can be used to host the application. If the GovCloud is used with a IL2 application, then the application can reside anywhere on the GovCloud. However, if the application has IL4 or IL5, then the application must reside in a secure area of the GovCloud which is protected by rules defined in the Secure Cloud Computing Architecture, or SCCA.
If the application is declared to have impact level 4 or 5, Then the cloud access request needs to be directed through a DISN network facility, such as the NIPRNet. If the user is not on the NIPRNet, a connection needs to be established from the Internet to the NIPRNet. This is referred to as the Internet Access Point, or IAP. Also, as we mentioned, the IL4 or IL5 application needs to be hosted in a section of the GovCloud with enhanced firewalls and management products referred to as the Secure Cloud Computing Architecture, or SCCA. The DoD will procure as a dedicated connection between the NIPRNet and the GovCloud to support the BCAP. This connection will be isolated from the general Internet. The BCAP will include its own cyber defense capabilities such as a firewall and intrusion detection and prevention in order to protect the NIPRNet from the application residing on the cloud.
Numerous applications reside in the multiple networks, all accessing the different cloud data centers from different networks. A user on the Internet would gain access to the Impact Level 4 or Impact Level 5 application by traversing through an Internet access point to the NIPRNet, and then navigating through the boundary access point to the mission application, such as is depicted in this animation. These concepts of the Internet Control Access Point, Boundary Control Access Point, SCCA, and Mission Application can all be represented in a logical cloud network diagram.
This new diagram represents the same concepts as we saw in the previous diagram. However, this diagram allows more details to be described within each section. This new diagram is the standard architecture diagram, as presented in the AWS Security Guide as part of the DoD Cloud IAC initiative. Understanding the components of this diagram will help you understand how the DoD Cloud IAC is put together.
Let's trace through this diagram, in the same manner that an Internet request might traverse through the network. Let's start by assuming that the user logs in from the Internet. The first step is to traverse the Internet access point and connect to the DoD network. Generally, this will be an attachment to the NIPRNet. From the NIPRNet, the boundary cloud access point to be accessed, and the connection to the cloud data center will be initiated. This traffic will flow over some type of dedicated connection like AWS Direct Connect. Let's watch that transaction take place. As noted, Direct Connect provides a dedicated connection, without going through the public Internet. This will both provide enhanced security, as well as high performance. Remember that the purpose of the Boundary Cloud Access Point is to protect the DoD network from the outside world. Protecting your application from the outside world is the responsibility of the SCCA.
As we connect to the cloud data center, we need to recognize that there are many cloud data centers across the world, and the cloud data centers are organized in a manner to provide the correct security profiles and location proximity. Zooming into the diagram, we notice that the components of the diagram are based using a logical organizational construct, called the region. In this case, it is labeled as AWS GovCloud Region. Let's dive into that a bit.
If you were to read the AWS documentation, you can see several maps that show all the AWS regions across the world. In this map, we only selected North America. On this we see orange circles, which represent regions, and blue dots, that represent edge locations. The edge locations are primarily used to cache data to make it more efficient to access. We'll be focusing on the orange circles, the regions. Zooming in, we see 8 regions across America. These are represented with black, yellow and multicolor squares. Looking into each of these squares, you can see the impact level supported, and the number of availability zones each region has. In the cloud, the term availability zones is used to denote each data center located 50 miles apart. Although one availability zone may actually have more than one building, it is easy to think of these as independent buildings located far apart. Most of the regions throughout the United States have 3 availability zones. However, the U.S. East region in Virginia has 6. There are 3 types of regions represented in this diagram: public regions in yellow, which can be used for IL2 applications. The red, white, and blue regions are GovCloud regions, these are located in Ohio and in Oregon. And the black regions located in Virginia and Ohio, these are classified regions.
Returning to the transaction flow, the transaction enters the region, and based on the IP address it navigates to a virtual private cloud. The virtual private cloud is often referred to by its acronym VPC. The VPC provides a level of isolation within the cloud environment. This is achieved through the allocation of a private IP subnet and a virtual communication construct such as a virtual local area network or VLAN. The VPC is accompanied with a virtual private network, or VPN, that secures remote access to the VPC. All taken together, the VPC creates an area that is virtually private, hence its name Virtual Private Cloud. In early cloud environments, communication between VPCs required that a request be directed out of the cloud region into the internet, and then the request would be resolved back into the cloud region, to the target VPC. This process was burdensome, and had negative impacts both on security and performance of the request. As a solution, a product called the AWS Transit Gateway was developed. This product ensured that the communication between VPCs stayed within the cloud environment.
The AWS Transit Gateway provided a central hub for processing requests between VPCs. The SCCA architecture leveraged the Transit Gateway technology and the VPC technology to create a set of isolated areas to deploy the SCCA. The SCCA Virtual Data Center Security Stack, or VDSS, is contained in one VPC, and the Virtual Data Center Managed Services, or VDMS, is contained in a separate VPC, and the communication between these VPCs and the mission VPC is maintained through connections in the AWS Transit Gateway.
The VDSS provides network security capabilities such as firewall, intrusion detection, and intrusion prevention systems. It also provides application security capabilities such as web application firewalls and proxy systems. The VDSS normally resides within the cloud service provider's infrastructure, and will protect DoD mission applications that are hosted in the cloud. The VDSS performs the bulk of the security operations in the SCCA. It conducts traffic inspection to secure the applications that run in the hosted cloud environment. The list of VDSS requirements include the following. Reverse proxy capability. Inspect and filter application layer conversations. Distinguish and block unauthorized application layer traffic. Detect and report malicious activities. Stop or block detected malicious activity. Capture log files and event data for cybersecurity analysis. Archive systems data for common collection, storage, and access to event logs. Provide key management system for private encryption key credentials. Detect and identify application session hijacking. Full packet capture. Packet flow metrics. And the inspection of VPN traffic. For more details on the SCCA and VDSS, refer to the Department of Defense Secure Cloud Computing Architecture Functional Requirements Guide.
Now that the web request has been scanned and we feel confident that the request is valid, we move on to the next VPC managed as part of the SCCA. This is the Virtual Data Center Managed Services, or VDMS. These services focus on ensuring management and compliance of the mission application. The requirements for the VDMS include Assured Compliance Assessment Solution, ACAS. Host-Based Security System, HBSS. Support CAT card access. Configuration Management System. Directory Access Service, Directory Federation, DHCP, and DNS. Event Logging and Archiving. Provide DoD Privileged User Authentication and Authorization. Support the role of a Trusted Cloud Credential Manager, TCCM. The VDMS VPC is essential in helping provide a robust managed and compliant architecture.
An example of a service managed by the VDMS would be to provide an Assured Compliance Assessment Solution, or ACAS. Compliance assessment can be performed by many tools. In the DoD Cloud IAC environment, the tool AWS Config is used. The compliance requirements for the cloud environment are documented in the DoD Cloud Computing Management Guide, or CCSRG. Let's take a look at one of these compliance issues. Digging down in the CCSRG, we can see the many controls that must be enforced in order to ensure your cloud environment adheres to the compliance rules of the CCSRG. In this example, let's drill down into Rule SC13. This rule covers the area of system and communication protection and the use of cryptography. Combining the control text with the value text, we see that the application requires a FIPS validated or NASA approved cryptography over the information in the cloud.
If we continue to research the SC13 control, we can navigate through the Defense Information System Agency Security Guide for AWS and look up the requirements for SC13. Researching this topic, we can see numerous control settings that the AWS security ensures we set in order to maintain compliance. We can choose any of these. However, let's look into setting the control on the simple storage service buckets to ensure that encryption is enabled. The simple storage service goes by the acronym S3, so the S3 bucket server-side encryption enabled setting should be turned on.
Let's go back to the AWS console. The tool that we plan to use is called AWS Config, the menu listed as Config. Searching down a bit, we find the Management and Governance area, and in the middle we find Config. Let's click that and look at the console. As a reminder, I posted the snippet from the DISA AWS Security Guide which references the control that we need to make sure is enabled. This is the S3 bucket server-side encryption enabled setting. We search for that setting in AWS Config and enable it. Now we need to decide what action to take if we find a S3 bucket that is not encrypted. AWS Config not only reports the violation, but in some cases can provide the ability to remediate the violation. In this case, we configure AWS Config so that if it finds a S3 bucket with encryption turned off, it will automatically turn it back on again.
In this illustration, we showed how to configure the AWS config setting in your AWS console. However, in reality, you'll probably be using DoD cloud infrastructure as code settings. Therefore, the cloud configuration expert can use the DoD provided scripts to conduct this work for them. You can see the example of the CloudFormation code, which is the infrastructure as code scripting language, as it configures the AWS config settings. If the DoD IAC scripts are used to build your environment, you can assume these settings have been configured for you. AWS config showed the manner that the VDMS would both monitor for compliance, and in cases where it is possible, remediate the compliance issues. From this point, the transaction has completed processing through the SCCA components, and now can use the AWS Transit Gateway to navigate to the mission application.
The Mission VPC will use Identity and Management Services, IAM, to validate that the user is allowed to use this application. Once validated, the request will be processed. In this diagram we show the request first being load balanced to a web server to provide a HTTP and HTML interface to the client, then to an application server, where the business logic is conducted, and finally to a database server, where the data for the request is processed. There are many possible configuration scenarios. This is one of many valid choices. As the request is processed, events are logged. The AWS CloudTrail facility will record every Cloud API call that the application made, and store the trace in a S3 bucket, and the CloudWatch facility will collect metrics on the transactions to ensure the site and request are operational.
At this point, the transaction is completed, and the responding web page can be returned to the user.
We have been reviewing the AWS Security Guide, understanding the flow of a AWS Cloud transaction through the DoD SCCA compliant architecture. However, building this environment is another issue.
The DISA AWS Baseline Deployment Guide will provide you the overview on how to create this environment. DAU provides an overview of that environment in Lesson 5 of this micro-learning course series.
Now that you have gone through an example of what your target environment will look like, you will see a considerable overlap on what your IAC deployment environment will look. Hopefully, this will help you to understand why the deployment is being conducted in the manner that it is.